special applications for smart cities, an integrated approach. Because as Dr. Mukta talked about how geospatial technology is not a single technology, but a suite of technologies that are weaved together to give an end user experience. So that's why we need to have an integrated approach with respect to the technology adoption, technology understanding of the technology, and then aligning the technology with aligning the technology with
Yogita, you need to share your screen.
Yeah, somebody interrupted.
No problem.
So so we need to align it not just between the geospatial, the different technologies between the geospatial, but also align it with the business and process flows of the user segments. For example, if we are talking about smart cities, then smart cities is not just one segment or one domain. There are multiple user areas in smart cities. So we'll be talking about that. So, and why do we need geospatial also? See, Urban India 2030, the scenario is like this. We require more than 700 to 900 million square kilometer of commercial and residential space to be built. Then there would be almost 270 million additional working age people. 70% of net new employment will be focused in the cities, and we would be adding 68 cities in India who would have a population of more than 1 million, and we would adding like about 590 million people to those cities, and the amount of investment that would be required would be like $1.2 trillion capital to build these cities. And so we need our cities to be smart enough that they use innovative measure, optimize the use of resources where they reduce the carbon footprint, and then transform their the urban transportation, reduce waste, and promote recycling. So we are all aware that cities right now are plaguing with these challenges of excessive consumption, and the solid waste management, the recycling, the commuting problems we are having with the traffic jams. It's a daily nightmare for all those who are into metro cities, and the same is being now replicating in tier 2 and tier 3 cities also. So how do we then innovate and optimize the resources? That is through the use of geospatial, because geospatial provides us the spatial understanding of our environment, the context, and all the infrastructure augmentation and development that is required for smart cities inherently would need geospatial technologies. Secondly, why do we need geospatial? Because it provides us an integrated view of the city. We can get in a single snapshot one view of the city, and then it will also help in management and monitoring of projects and operations. So like we have different verticals in a city, for example, property taxation, we have water supply, we have electricity supply, we have stormwater drainage, we have solid waste management. So all these activities by municipal corporations, they can be brought together, and we can have a combined and integrated view to properly manage and monitor the same. And result, as we said, would be improve governance and decision making, citizen engagement, and safety and security. Dr. Mukta has already talked about why geospatial. I'll just provide you the entire snapshot in one. So how is why geospatial is connected, the query, the information needed, and the impact. For example, whereas this is supplemented by the coordinates, and the impact whereas this create is the spatial awareness. So one is aware of where they are when they are presented with the information, what we call as coordinates, and the spatial data. Then what is happening here if the query is that the information required would be any event at the location, and again it will provide the spatial context. So similarly, we have, like, for each query, the information needed is provided in a integrated fashion, so that there is a desired impact which we are looking forward to. So geospatial provides this linkage. It provides a single view of the query, information need, and impact. Again, why geospatial? Because it provides us with the reality mesh models. So you can mesh the predictive models with what is existing on the ground. And right now we are all aware of the concept of digital twin, and we are seeing alive many 3D models where of the cities, where we are able to go through models. So models are not just for the visualization purpose, but they are also for the virtualization purpose. So you actually get a virtual model of your city, and that's where geospatial becomes very, very important in city management, because the cities are not just growing horizontally, but they're also growing vertically. So 3D modeling and 3D management is a thing which is required in the current scenario. Then again, we talk about why geospatial, because it is an interdisciplinary domain. And what we are now going to talk about is that the focus is going from not just content, because we all whenever into our minds. So it is basically from the content, which is either a 2D content or a 3D content, to deliver solutions that are enabling the user. So it is integration through the geoinformatics, convergence, like your ERP, your SCADA, your consumer relationship management, CRM, all is system related, and also the engineering system like BIM and the likes of this CAD was earlier there, but now the building information model. So this is embedment. So I'll just give you a quick overview because Mukta has given in the detail the geospatial technologies and the process flow. So we have to understand this, and every user needs to understand that geospatial technologies, they are working in a certain harmony and in connection with each other. So we need to understand that how we connect these pieces together to deliver a particular solution. And therefore what we need to do is we have to match the application to content. Right now what is happening, and I've been interacting with a lot of cities, they have data, they have maps, they have all the content available with them, but then the issue comes is that they're not able to integrate, they're not able to converge data, able to optimally utilize the data. They're not linked to the application. So when we are talking about the geospatial process, first we have to identify what are the applications which we are going to cater for a smart city, and then work backwards to the data. What kind of data? So the first activity before even going for a capture of data, we need to go and we have to have a spatial data model. Spatial data model catering to that particular application. So that particular application can be a property tax application, or it can be a solid waste management application, or it can be a water supply application. Once you have the data model, then you realize that what kind of data you would be requiring to cater to a certain applications. And then we can acquire the data, whether it is from the modern survey if we are requiring, or GNSS satellite imaging, aerial photography, UAV, mapping, BIM. So based on which application we need to cater to, we have to identify. So we can have a combination of, say, modern survey, GNSS, and satellite imaging for property taxation, because from satellite images, we can do the feature extraction for the base map. And from the modern survey and GNSS, we can go to the ground and match that data to the ground coordinates. So what satellite imaging is supporting here is that satellite imaging is augmenting the survey methodologies. It is reducing the time which is taken in the field with respect to capturing the spatial content. And then once we have, like, whatever data we have acquired, then we have to do the data processing. So if we are acquiring, say, for example, aerial photography, then go for photogrammetric processing applications. If you are using satellite imaging, now with high resolution satellite images, we also have to go through photogrammetry. Then if it is a medium coarse resolution, we can go for digital image processing, image interpretation like vectorization and digitization. Then we can also use GIS, because GIS is not just for integration of spatial and non-spatial data, but you can also create the data using a GIS platform. And then you have to convert the update and update the existing database which are there for, say, for example, you have information in CAD database. Then you need to convert that CAD database into a GIS ready format. So all this processing is required. Then LiDAR data, it requires a different processing techniques. So we have to understand that each of the spatial data which we have acquired require a different processing technique also. And we have to link the acquired data to the processing. And then comes the next part is integrating the data, analyze it, and model it. So this is where now we are developing what we call as enterprise geospatial systems. And here the integration would be between the spatial and the spatial, because as we saw that we are getting spatial information from different technologies and different methodologies, different processing technologies. So we have to have an integration between the different spatial information also and spatial to non-spatial, and we have to see how they are interoperable, how they're the formats can be exchanged from one format to another format, and we don't. And then we have visualization and dissemination of the data which we have done. It can be through desktop, web, mobile, tablet, cloud, and other platform. And with mobile and tablet and web integrated, it's a whole new gamut of applications which we are now getting in, see it. And then update and maintenance. So with geospatial information, this is a very critical aspect, and it is there where it differentiates itself from IT, because IT system, once you have deployed, once you have implemented, it gets automatically updated with the data, with the information. But in case of geospatial, because you have to capture spatial information on a regular basis, on a regular frequency, and there is no automation which can be done right now. There is no automation where you can automatically update and refresh the data. So you have to be very, very particular about this aspect while you are architecting your entire geospatial system. If you don't, updation and maintenance of your data, then the data would get redundant within 6 months or 1 year, and you have to again start afresh, because rather than updating that data, refreshing the data, it's advisable to get the data new. So that geospatial, how it is, we can have the alignment of geospatial with the smart cities. So smart cities, if we talk about a city life cycle, it involves planning, designing, building, operations, management and maintenance, and sustainability. So when we talk about planning, it starts from master plan creation, site selection and land valuation, planning and simulation of public order, safety, law, and security arrangements, and environmental impact assessment. So, right when you are right at the start, you have to have all these maps, all these data, all this information readily available with you, so that for any city, if you have to do a planning, even whether it is a new city you are planning or whether the current city you are planning to expand, you need to have this information ready in your hand, where you can then analyze and then you can guide your planning exercise. Then we come to design. So once you have planned, once the planning is done, then you have to design whatever things with the architects, the models which are built, and with the integration of BIM technologies with geospatial and coming of lidar, the designing activity can be linked in a seamless fashion after the planning activity, because you have those as built models available with you, and you can create those reality mesh where you can mix and match. So you can do your infrastructure designing of bridges, flyovers. You can do the mashing with underground utilities, storm water drainage. So here what you can do is you can have the existing data in your 3D as built drawing, and you can overlay what you are planning. So and the design which you are planning, whether the two are matching or not, because sometimes it is only after construction you realize that the design which was done, it doesn't match really when you are constructing it. And then comes the building aspect. So you have the construction planning, land acquisition. You can even go for a smart and green construction, go for the green construction, where you identify the kind of materials which would be required, because the machine control and automation technologies which are now really coming up, you can also measure, or you can before, because from the design you can understand what is the quantity which will be required for building a particular infrastructure. And then we come to the operations, management, and the maintenance of the city, so which is a very regular activity. And these are the applications where you have to get the property taxation on a regular basis, where you have to maintain your assets, your utilities, your solid waste management process, your service delivery, even the pollution emission analysis, the traffic management finding. You can also do the project monitoring your infrastructure development, and then you can do the social media analytics and mapping. And the fifth pillar of this is that these sustainable solutions, they are need to be working on a continuous basis, and we need to also now add the virtual and augmented reality, and we can have a predictive planning also can be done for the future based on the historical information or based on the existing information which we have of our city. So now I'll just give you a snapshot of how we can, match the geospatial vis-a-vis the city life cycle. So the spatial data to processing, how each of these components we have to match with the city life cycle. So in planning, we can have information. If you are going for a 2D planning, we can get from photography combined with GNSS. And if we are wanting to go for a 3D planning, we have to then build in the LiDAR and aerial photography together with GNSS. Then at the design level, we have to the integration of LiDAR, 3D city model, and information modeling. When we are constructing the 3D city model, modern surveying and GNSS, machine control and automation, and a host of geospatial software, which may include your 3D model software, your LiDAR software. So that is, and then when we go to the operations management, it is a collaborative workflow for property taxation or utilities or all the applications which we are trying to build in. And in sustainability, we have to have all of these where we need to have a strategy for continuous evaluation and assessment. Smart cities and geospatial. So as we see this picture, it talks about why geospatial is important for smart cities, because the information which is built around the cadastre, the utilities, the climate and environment, the governance, the infrastructure and transportation, which are the major segments the smart cities would be catering to, they are inherently linked. So your cadastre data is impacted by your it is connected with the utilities data. It is also connected with the transport data, and the cadastre data is also the base data for your transportation, for your utilities, for your infrastructure, for your governance. So this is the kind of linkages, and that is why when we are talking about geospatial technologies and smart cities, we have to consider an integrated framework where we can build the connectivity between all these different segments. And geospatial is the one technology, where which is building those connects, because the common denominator here is the location. This common denominator bring together all the other questions of your how, why, when, what. So while the other technologies can give you the answer of how, when, why, what, all these integrated together by the where. And that is why the importance of where is there. So how do we do this information and information flow and synchronization? So a lot of spatial information needs to be collected. So there has to be a foundation topographic information, which is your topographic base map derived from a high resolution satellite imagery, ground-based survey, LiDAR data, ortho-based map, a 3D base map, and the 2D and 3D cadastre. So in the foundation base map, your cadastre also plays a very important role when it comes to your cities. And then we can have a domain specific information where we capture the property information, the road network, the bridges, the flyovers, the water bodies, the water supply network, the electricity supply network, metro network, underground utilities. So all these are domain specific information, and they needs to be captured by the domain organizations who are dealing with these utilities or these services. And then when we built the solutions and application on the top of it, then we get a smart transportation, because your smart transportation needs a topographic based map, both in 2D and 3D. It also needs your satellite imagery at the backdrop. Then it needs the network of your bridges, your metros, your road network. Then the solution, property taxation, it requires not just a property information, but with that property, whatever utilities are linked with, for example, water supply. I'll give you an example. In Ghaziabad, the property is linked to, like, we have to pay taxes, so each property is linked to the water supply. So we pay the, not just the house tax, but we also pay the water tax and the sewer tax together to the municipality. So municipalities can integrate the property taxation data, the utility data from the water supply, and the sewerage data, and for each household, what is the taxation coming from each, they can derive from in each household. So if a household is a small, so right now there is a one fit solution for everybody, that is the area of the house. So we can look into different applications, and then we can have a consolidated view of the city, which is for the decision makers, as a dashboard, where they can get a view of their entire cities, how the different functions are operating. And synchronization has to happen both going upward as well as downstream. So it is not the one-way synchronization that has to happen. The information which is being changed at the dashboard also needs to be reflected at the foundation and the topographic information. We all are aware, as we talked about the smart cities, in the city life cycle, the application, the planning, operations, and maintenance applications, and the other applications are the design and construction applications. So going with the thing, even in the smart cities, we have differentiated between the two. We have a pan city applications, and we have some applications which are area based applications. So pan city applications basically, can put together, if we talk about the city life cycle, into the planning applications and the operations, maintenance, and management applications. So these can be both in 2D and 3D, and they are basically to facilitate governance. They are also there to help citizens, and maintenance of utilities like leak identification, their customer management thing. So, for example, if you have a outage and if you want to complain about it, so having a dashboard, a 2D dashboard, you make a call to your electric utility, they are able to identify that which household is having that, and I can tell you that by what time your issue would be resolved. And similarly, for built up areas, you can have for environment, climate applications you can have, and for your safety and other applications. So I'll just give you that for each of these applications, what we need to do is align the geospatial with the business workflow of that particular segment or domain. For example, if we talk about property taxation workflow, it starts with self-assessment, then survey, then verification, then you evaluate the property taxation. This activity is sustained on a regular basis. So when you are doing assessment, you may require a mobile application and map-based online property taxation form. And then when you're going in the field to do the survey, you have a mobile application you can use on the amount of information. And then the verification can also be done through satellite imaging or aerial photography. So this is how, like each of the segments, each of the work area where the property taxation information is collected, which geospatial technologies is aligned, we have to first match that. And the similar activity has to be done for all the sectors, for example, your utility sector, for example, of your solid waste management, how the solid waste management flow is happening, and which geospatial technology or application will suit to that particular activity. Then the seamless integration. So as we talk about the geospatial integration, it is between the spatial to spatial integration and the spatial to non-spatial, and lot of different services. You have map and geoprocessing services, you have image processing services, you have metadata from catalogs where you bring those, then data from location, then you have collaboration services. You can also build in the SMS services and the IVRS services also onto this. And then integration is happening. And then if you see the custom solutions, we have, like for each applications, we can have a property taxation revenue, building bylaws, birth and death registration, dashboard reportings, solid waste management, sewage management, water supply management, street lighting, and other services. So, so this is it is being implemented in a lot of cities in India, and a lot of smart cities like the Surat smart cities. They have already done a lot of integration at application level and also at the business level. But the complete end-to-end integration has not yet happened. But a lot of integration has happened, and a lot of integration is in process. There are a lot of smart cities which are looking into these kind of integration, where their integration, they have also prepared a integration framework with your command and control center. So yes, it is being, and it is a very robust activity, because the geospatial information in itself is data intensive activity, and the data is very robust, and so it takes time. And now we are going from 2D to 3D. The robustness of data is also going to enhance. So the integration, when we are talking about, it has to be at all the levels. So at an information and data level, we have to have the integration. We have to have integration at the platform levels, where we are integrating the different platforms like the GIS, the ERP, the SCADA, and then the integration at the application level, where we are having an integration between application which is a property tax application, and then an application which is a electricity application. So I'll just give you how this integration is helpful with this. Like we can have a GIS based web platform, and we can have all this information fetching into that particular web platform. So these are the integration with prime municipal functions, and then integration with engineering and other applications. So the prime municipal functions are property taxation, water billing, finance and accounts, city portal, electricity, mobile applications, solid waste management, health schemes, welfare schemes, and the engineering, the asset management, material management, land and estate management. So I'll just give you an integration use case of a municipal corporation where a property data from ULB and electricity data from utility was integrated, and this cross integration and cross verification talked about that there were residential properties who were assessed. Almost 8,000 were the assessed properties, but 37,000 properties were the unassessed properties. And like it was in electricity consumer data, they were the consumers, not the residential consumers, but uh, this commercial consumers. So what happens is that you may have a commercial connection of the electricity, but the property you declare it as a non-commercial property. So when we are cross-verifying it, we can verify that whether if the consumer, the electricity consumer, is a commercial consumer, but the property link is a non-commercial property. So similarly, if you can raise your tax, because the tax for a commercial property is more than the residential property. So this is how, like as I said, that 45,000 consumer data were found. They were non-residential properties. So with this kind of integration and with this kind of cross verification, both you can increase the revenue of your property taxation, and also you can go backward and increase your revenue of the electricity data also. So for a project life cycle, these are the phases we need to have. When we are architecting a geospatial project for a smart city, so we have to prepare a project implementation plan. So before embarking on any geospatial project or activity, we need to have a project implementation along with the revival and upgradation of existing data or any legacy GIS system. Then we go for geospatial data preparation and survey. Then we design, develop, and implement an integrated city enterprise system. We set up a dedicated GIS cell, and we do the capacity building and the training of that particular city. We need to have a systems approach when we are deploying any geospatial project pertaining to smart cities, because it is going to be an integrated system. So we have to do the analysis and design of what is existing with the city. We do the workflow analysis for various business processes, like your property taxation, your electricity utility, your water supply. And we also do the user requirement analysis, that what applications would be required by a particular user for that particular city. And then we develop a systematic architecture and a system requirement document. We do the data assessment as to what the current data they have. Then we do the geospatial database design. We do the application design and the data conversion. And based on this analysis and design, then we develop the geospatial database, the standard, the priority application, the training plan, the integration, testing, and then we deploy that system. We test, we train, we install the infrastructure. We start using the priority application area first, and then we build up with the next application areas. And then we do a continuous documentation, we do support and maintenance, we do performance monitoring, and then we, so this is a continuous activity which we do when we are deploying any geospatial system, particularly with reference to smart cities. We come to the area-based development. So the area-based development, the two aspects of the smart cities life cycle it will be catering to is the design and the building. From the and this would be more of a 3D data set and not the 2D. And that is why it is being implemented in pockets right now to understand the the usability, the efficiency, and all, because 3D data modeling is still in the infancy when compared to the 2D applications of geospatial. So talk about is that this is how we'll build the virtual urban model for the smart cities, where we have an intelligent rendering of the cities on a continuous basis, and it will facilitate energy analysis, detailed architectural visualization, and interactive and immersive applications. So, so when we are building the smart cities into a 3D, you must have been come across this LOD, that this is the LOD requirement for the application: LOD 0, LOD 0.1, 0.2, 0.3, LOD 1, LOD 2, LOD 3. So when we talk of LOD, that is LOD 0, it gives you the dimensions, or it gives you the information, spatial information in a two-dimensional structure, the area, and then that two-dimensional can put together in a 3D format. As we see in the LOD2 and LOD 0.2 and LOD 0.3. And then we come to LOD1, we get the outer dimensions of any particular infrastructure. So we do not get the details of the structure, but we get outer dimensions of that particular structure in a rectangular form. So means I need not explain, because pictures, this picture is LOD 1.1, 1.2, and 1.3. And then the LOD2, and the highest level of detailing which is done is LOD3. So when we are creating the 3D models, we have to understand detailing we are looking forward to. So for example, if you see this LOD 3.3, you can even have the balcony there, and the internal arrangement of your building, you can build to that level. So this is where the geospatial is for the infrastructure development, and the 3D thing where BIM is integrated with geospatial, and this is the kind of virtualization you are able to get. So your underground utilities are there, your street lights, everything is there. It is modeled not in virtuality, but in a reality. So the real model is brought into a virtual environment where we can then play with the data and we can build on it. So it can be the above ground for transportation networks, full spatial orientation, 3D buildings, pedestrian networks, and below ground for water and water sewer systems, phone systems, electrical systems. So this modeling, it has the real coordinates inbuilt into it. So you are able to understand, where there is where there can be a clash detection between the utilities. Thank you so much.